Okay, the next one will be the tools and technique. What is Six Sigma? What is the cost process, concurrent engineering, and so on. Right. So these are two textbooks that I use just for info lah. Just for info. So this section I'll go very very fast because a lot of theory you can read on the slides. Okay. Okay. So why we need a process? Why we need quality? Why in the new product development? Why we focus on quality and Six Sigma? It is because we have three aspects in a new development. One is quality, design to Six Sigma, design to cost. So the way you design, it depends on three main streams. One is you design it because you want to improve the quality, right? Number two, the design to Six Sigma is you design the process so that the process is reliable, it's always within the control limit. Okay, or you narrow the defect, means you minimize the defect in the process. The third one is design to cost. This one is more on the process, how you choose the best method to manufacture it, the most effective material, and so on. This one you read. Okay, so Six Sigma you already introduced in the previous lecture. Right. So Six Sigma is under total quality and continuous improvement. Okay. Sigma. So the focus of Six Sigma is on QA, quality assurance, continuous improvement, and fix them. If there is any point out of control, you fix them. Okay. So the one that you learned in the previous lecture to find the ULC, that one is under Six Sigma dimension. Okay. So again, recap what is Six Sigma. So it based on what is the region that you are in. So if you are 1 sigma, then it's 58% data is within your control. Then if you are controlled by 2 sigma, means you control 95% of your process. If you have more than, this one is wrong. This one is 99%, not 95%. Okay. So if you have 3 sigma, it's 99.5 something. Okay. So some numbers wrong here, not 95, 99. Okay. This one you read. Okay, so this one designed to cost mean you focus on the cost. You do all means to reduce the cost and while meeting the customer requirement. Okay, design to process. This one is you simplify the process. If any process that you can take out, you take out. If any process that you can go parallel, you go parallel. So these are the things that can go very, very deep, especially when you go to management, school of management. So they'll go very, very deep in all these title. For example, concurrent engineering. Concurrent engineering means you go things parallel. You work things parallel. The same process line, but same process happen. Different parallel process happen, concurrent. Quality function deployment, QDF. This is more on the quality side. Rumbus design, RD. Rumbus design is more towards optimization, design optimization. SCD, statistical process control, is already learned just now. The upper control, lower control, that one. Cost of poor quality, COPQ. This one another tools for you to calculate the risk of your process. Like why suddenly a lot of poor quality come out? What is the effect? All this evaluation is on the screen. Okay. concurrent. The word concurrent means do at the same time. Do at the same time. Okay, this one you read lah. So concurrent, one of the example is that nowadays if you use software, your software can run at the same time at different country. And nowadays if you use AutoCAD or other software, you can even produce a drawing at a different country on the same drawing. It's like Excel spreadsheet, or you share in the Google form. Your team can edit at the same time. Okay, so that is called concurrent. Okay, for example, concurrent engineering happen in Petronas process, oil and gas, where in KLCC on the top, KLCC is a Petronas office. You will see a lot of statistic monitor. If you're able to go in, you will see a lot of monitor there, and even they can control the oil platform from the KLCC. If the oil platform is in Saudi Arabia or this, they can control from KLCC. Okay, they can even know the oil flow rate, the oil fill rate in the KLCC, what happened in throughout the world, the oil rig that I have. Okay, then what happened, and then they can deploy repair at a very fast. So they don't need to wait for anything. So if anything happen or catch fire, you'll see all the signal come up and all this. Very sophisticated center lah. Okay. So again, Six Sigma, you see the same graph again. Okay. So these are textbook definition what is concurrent engineering. This one you read lah. Okay. This one is the concurrent engineering wheel. That people, when they teach what is concurrent engineering, they use this diagram. So they have two cycle. Each one is one product, then they link the two process together. Okay. So what is important in concurrent engineering is have 1, 2, 3, 4, 5 steps lah. Okay, important is concurrent, you need multidiscipline team. Then you using the expertise of the team, you try to solve problems. Okay, these are the things lah. Okay, this one also you read. What is DOE and Taguchi? This is rhombus design. Rhombus design, it means you have a product of minimum quality losses. So you have two tools to use. One is DOE, one is Taguchi. Design or experiment. This one you read. So a traditional design or experiment, DOE, is very good in preliminary. Taguchi is a Japanese. He introduced quality optimization. He's an engineer and also a statistician. So Taguchi actually used statistic approach that you learn in your mathematics. Hypothesis what, then sigma, more or less. Okay. Loss function. These are all the definition for the terms. What is concept? What is system? What is parameter? Design or rhombus design? What is tolerant design? I think this one you read. Okay, so this one you already exposed to all this information already. So we go very detailed in how to do the SPC or statistical process control previously, right? So again, important is the mean, upper limit, lower limit, then the y-axis, x-axis. Okay, so it depends on what kind of chart you want to plot lah. Okay, you can P chart, C chart, mean chart, range chart. Okay, So again, it's just a revision. Actually, the ULC and LLC is the statistics normal chart, normal statistic chart lah. Okay. So these are the 4 steps for SPC. I highlight in the blue color. You measure, you control it, or you eliminate the cause. You monitor, you improve. Okay. 4 steps in statistical process control. These are the 4 steps. You measure, you get data, you control it with or you eliminate, find out the cause, why it happened, then you monitor, then you improve. Yeah. Okay, another one is the Six Sigma, and this one is from this book. So this one is a bit detailed, but this one you read as your information. So in Six Sigma, they have something called system input and output. You go inside a system, you must have an input and output. Okay. So this one you read lah. So there's an example of this system input and output things. Okay. So this is just an example lah. Important that you know that system have input output. Okay, the rest you read if you're interested. Okay. Then this one is another example how they evaluate the things. In this case, it's the barcode scanning in the hospital. So they want to consider all this lah. They want to achieve shorter shift hour, the nurse loading, the nurse look after a fewer patient and so on. Okay, then they set up the input and output things in the system, then they monitor. Okay. Example 3 is the welding robot arm. So the shape of the weld is related to profit. If you're able to weld nicely, your maintenance cost will be minimized. The reject will be minimized. Right. So you want to investigate the robot setting to affect the welding quality. For example, weld speed, voltage, the wire feed speed means if this robot arm, there's a welding robot arm, you have a speed of welding and there's a feeder there. There's a wire feeding speed there. Time in the acid bath, weld touch, contact, tip work, distance, and so on. So you have input, output lah. Okay, so your input and output. So input is what you can control or what you feed to the machine, like the voltage, tip distance, all this. Then you go through the computer inside. Then output is what you can see, what can smell, what can touch, all these things. What you can measure, all this. Okay, Six Sigma. This one you read. What is Six Sigma? Blah blah. This one is a textbook definition. So Six Sigma, they use phrases DMAIC. DMAIC. You define, measure, analyze, improve, and control. This one already done already. Okay. And then this one you read. Okay, so Six Sigma, they conclude in 2 principles. Principle 1, you justify the cost. You justify the cost. Principle 2, you find out what is wrong with the statistic method. Means you use statistic method, investigate what is the process flaw or what is wrong with the process or something wrong at whether it's randomized or non-randomized. Okay. So this one is management. This one you read. Okay. So this is just some history on the management. So they have a steam engine, railroads, motor, and so on. So this is comparison between the industrial era, what happening. For example, steam engine this year, automotive this year, supermarket, Walmart, and so on. Toyota, Ford, and all this. Then they have different tools name come in. Okay, what year introduced what? Okay, now for example, how to do lean production for paper aircraft. You fold the aircraft. This is just an illustration now. Because if you go industry, it will go to a real case. This is just an illustration and concept how you do lean production or lean Six Sigma. So assume that you production floor, you want to make a paper aircraft or paper planes. So each unit, you have three process. You marking, you cut, and then you fold. You need these three process in your production. Describe the mass and lean way to deploy your resources, which might generate airplanes with higher quality. Now you want to do a products, then now you want to improve the quality by using lean Six Sigma. So what you do? Okay. So mass production method is have one person doing all the marking, cutting, and another person do folding. So this is the typical method, right? You have three process: marking, cutting, and folding. So maybe one of the approach in the process, you have one process that do marking and then do cutting in one process, then another person do folding. Lean way would have both people do marking, cutting, and folding to make complete airplanes. Means both person do same process, do marking, cutting, and folding at the same time. Okay, so lean way would probably produce higher quality because during folding, people might detect issues in marking and cutting. Okay, so this is the example. Okay, this one is nothing. So it means this is a cost, number of changes at the discipline company. So if in the beginning there's a cost go up, then at a certain time there's no more design need to change, the cost will go up, go down. Cost in dollar per changes in tooling cap is dotted line here is that after you start the project, the longer it goes, you need a higher cost to do changes. Okay. With respect to manufacturing, how can freezing design help quality? Okay, so this one is the one you read now. Okay, what is the difference between Six Sigma and Lean Six Sigma? All right. So again, Lean Six Sigma, this is not Lean Sigma, it's a Six Sigma and Lean production. You combine these two, it becomes Lean Six Sigma. Okay, Six Sigma is one thing, Lean production is one thing. You combine two, it becomes Lean Six Sigma. Okay. Again, Six Sigma is continuous improvement. You want to improve the system continuously. You want to do optimization. However, lean, you want to lean manufacturing focus on what form to be implemented for production system. Lean, we want to trim down the process. You want to trim down the process, reduce waste, and so on. Okay. This one you read. This is just a mathematics revision, how to find standard variation. Okay, you find standard variation given by square root of sum of x minus x bar square root divided by n minus 1. This is how to find standard variation. This one you learn in statistics. It's just a revision. So In statistics also, you learn something about half wave and full wave and so on. But I won't ask you this one in your assessment. This is just a revision, right? So this one you read lah, and you check whether information you're okay, not okay. Okay, so this one is just a recap on the previous slides. This one you input, output. This one input, output. This one you read. Okay, list two perceived problems associated with TQM. TQM is total quality management that motivate the development of Six Sigma. TQM might be too vague to workers to act on. It also might not be profit focused enough to make any manager to embrace it. So TQM, they might overlook on the profit side. Okay. This is just a recap. What is lean production way to make 3 sandwiches? Okay, you have 5 ways, 3 ways, and then answer which one. So you want to make 3 sandwiches, lay out 6 pieces of bread, add tuna fish to each, add mustard, fold all, and cut. Method number 2, lay out 2 pieces of bread, add tuna fish, mustard, fold, cut, and repeat. Number 3, lay out tuna, mustard, order out deep fried fat, bread, and wheat. So which one is the lean production way in making sandwiches? Okay, B, means you try to trim the process. Okay, try to trim the process and make it fast, make it production a lot, because your objective is to make sandwiches. Okay, now which of the following were innovation associated with mass production? This one you read lah. Which of the following benefit? Okay, this one you read now. Okay, these are all the things that you might heard in your internship or your future job. What do you mean by 5S? 5S related to your workplace to do 2 things. Increase efficiency. Efficiency is a ratio of your output and input. Okay, so means and then eliminate waste. There are 2, efficiency and waste. What are the 5S? This one very old approach, but it has been practiced in many places. So 5S is stop, strengthen, sweep, standardize, and sustain. So these are 5 things. So 5S is 1, you sort everything, go through everything in work area and remove unneeded items. You go do sorting, you make arrangement. See anything that you don't need, you remove. Okay. Then number 2, strengthen. Arrange everything in work area to promote faster work. All right. So you put the correct tooling at a certain place so that every time you do. So that's why some of the process you see the drill is on the top of the operator. The drill, they just pull the drill or the sprayer, the air gun and all this, they just pull and spray. Sweep, sweep means keep it clean. Standardize, there is a way of doing things, right? Standardize means there's a checklist. Step 1 do what, step 2 do what, step 2 do what. Sustain means you continue step number 1 until number 4. Okay, so this one is a carbine maker. So they do 5S. One you read. So this is a application of 5S. Right, you can elaborate lah. 5S. First step you do sort. Second thing you do strengthen. Third step you do sweep. 5 you do standardize. 5th you sustain. Okay. So this is 5 steps, 5S in the new development process also, right? So this one you can elaborate one. So you've got 5 steps, then you elaborate based on scenario. Okay, how you practice 5S in your process or in your company. Okay, so this one 5S is for improve productivity. Okay. Pokeyoki is we mentioned I think 2 lecture before this. Pokeyoki is prevent stability in the end user dimension. Okay, so this is SIM card. It's a mistake proving it's a mistake proving or stupid proving. Pokeyoki. So Pokeyoki method associated with 3 types of defect in engineering: contact defect, fixed value, and motion steps. Okay, so Pokeyoki, you have 3 types of Pokeyoki. First contact means you can able to identify the physical like size, color, shape. Fixed value is that operator is alert if proper numbers of movement were not made. Moving step here is determined if the step of the procedure is followed appropriately. Okay. So these are example. These are example. So in automotive industry, 1 person tighten 4 bolts with a manual tensioner. 2 out of 4 bolts require tension so and so 150, and another 2 require 50. These are production steps lah. Okay, so you need to tie up 4 bolts. 2 need 150, 2 need 50. It's a common issue that undesired tension are put on the bolt that fail to conform to engineering specification, because if you screw too tight, you also will make you are pre-stress the structure. So you're actually making the product actually fail faster, the shorter lifespan. So fail to mix up because of the mix up of the bolt type, because they screw different torque. So how do you prevent this one by Pokeyoki? Therefore, commonly some bolts are too loose while others are too tight. This one is the production problems. Right? Bending the bracket to which bolt attached. How might Pokeyoki be applied on which type of defect is relevant? So how you apply Pokeyoki methods is there are 3 types: contact, fixed value, or motion type. It depends. If you use type 1, you elaborate on type 1. Okay. So for example, if you use type 1 Pokeyoki, is contact. So your testing product can identify physical defect like size, color, and shape. So basically you are elaborating using size, color, and shape. So if you want to do tightening using 150 and 50, maybe you use different color board. So maybe the operator is of green color. Green color is 150, red color is 50, for example. Or there is a shape, different shape. The shape one, maybe you can use the square one, or you can use the 6 one, or the size big or small. Big screw is higher torque. Small screw head is lower torque, for example. Okay. This one, operator is alert by a proper number of movement. This one, fixed value, is on the machine, the screw, the bolt tensioner. You can fix value. Like in this position, how many seconds you press, or how many revolution of things that you need to fix the machine. This one, motion step, determine if the step of the procedure will follow appropriately. This one maybe is the way you screw the things, like how you rotate. You rotate clockwise or rotate anti-clockwise. So if you set the value correctly. So for example, 6 screw, this one 1, 2, 3. Maybe you screw this one first. This 3, then you jump, you screw this one, you jump, you screw this one, and you screw this one. Then you continue with this one, you change value of the torque, you screw this one, screw this one, screw this one, screw this one. Okay, so these are the Pokeyoki methods that you can choose in this one. So here, the example here, you use the Pokayaki type 3. So this one is a motion step defect. So this one is one solution will be split up the task, means two process. In the process, there's two table or two station. One station do high tension screwing, another do low tension process. Okay. Another option is different both head size and so on. Okay, so this is a Pokayaki process method. And this also, if you go out there later, we work as a design engineer or process engineer, this will be the thing that you need to think about. So where every time when the operator mix up something, you need to think of corrective action. You need to fill in the corrective action in the defect report card. So you need to design something. Sometimes you need to design where you station the process. Okay. Okay, so yeah, this is all the answer. What is Lean Six Sigma? What is Lean? What is Six Sigma? Okay. Principle of Lean Six Sigma. Lean is to produce waste. It's not produce. Avoid waste. Lean is to avoid waste. 5S. So describe possible application of 5S. Again, the 5S sort and all this. So try to think, try to remember the 5S steps. Step 1, you do what? Step 2, you do what? And then you elaborate. Yeah. So if the question asks you about 5S, remember, first step, you write what is 5S. Then you elaborate each one of it. How you do it. You just ask your answer. How I do this. For example, how do I do sorting? You just write out how to do sorting, for example. You write step 1, do what? Sort. You don't need, this one is elaboration. So you write step 1, sort, then you elaborate what you do. Number 2, strengthen what you do. Number 3, sweep, keep the workplace clean. All right. Then number 4, standardize what you can do. It's the checklist. Sustain. Apply previous step 1 until step 4, continuous with care. Okay. So this one can be half of the question. Ask you about applying 5S in one situation. So 2 mark, 2 mark, 2 mark, 2 mark, 2 mark, 10 marks for the first section A. Okay, one question is 25 marks. This one can cost you 10 marks. Okay. This one is hypothetically how you apply Pokayaki problem on your own life, for example. So Pokayaki, again, you have three types of Pokayaki things that you can do. Type 1, type 2, type 3. How do you improve or avoid mistakes in the operation? Okay. So these are the things that you can elaborate. Okay. So 2 marks here, 2 marks here, 2 marks here. Okay. Okay. So this is DOE. This one you read lah. This one you read. Design of experiment and regression. This one you read a bit deep. And then at least now what is important, you heard about all this term before. For example, 5 classes or experiment, you have these 5 things. We're not going deep into these things. It can be one module itself to explain the whole thing. Okay. So these are summaries of the tools that you can use. All right. Okay, so this one is the quick way. So what is important is this, you're going to read what is this table. Okay. Okay. Then this is another area on quality management. What this is the perspective. What is quality previously? What is the present one? For example, quality is blah blah blah. Now it's everyone's responsibility. Defect, quality defect should be hidden from customers. Now it become highlight and brought to the surface of corrective action. Okay, and so on. Okay. So these are the customers dimension. Okay, customer dimension means customer what they usually want, higher performance, product, higher quality, higher technology, material, and fewer defect, and so on. This one you read. What are the variable that affect market expectation? There are a lot lah, all these things you read. And then TQM, there's a definition for TQM. Quality definition again. So for example, Kodak, they use this triple point. I showed you this one before. No. No. Okay. So Kodak, they have this 5 quality principle. 1, 2, 3, 4. 1, 2, 3, 4, 5. About here lah. This triangular. Right. Teamwork, analysis, leadership, customer focus, and then continuous improvement. Then there's some certification, ISO 9000. This one is a quality improvement cycle. The famous Plan, Do, Check, Act. Plan, Do, Check, Act process. This is called Deming cycle. Deming cycle improvement. Plan, Do, Check, and Act. This one you read. Okay, this one you read. So Deming actually the main philosophy of Deming is they focus on the management, because they say the quality problem usually required management for decision, 85%. Then this one, another author or another researcher or another gurus, Dr. Joran, his 5 attribute. This one you read lah. Philip, another one, another guru. Okay. So they are various approach of quality improvement. Deming, Joran, Cosby. This one, try to remember 3 of this one. Deming 3, Joran 3, Cosby 3. Okay. Okay. Then conformance cost is training. Non-conforming is rework, production recall, complaint handling. This one is non-conforming. This one conforming cost. Okay, this one is an example. Okay, the example of this slide is say that there's a reject here and there. The moral is that you build it right at the first time. Means you do it right at the first time. Prevention cost, this one you read. There's a loss of cost. What is prevention, appraisal, internal, this one you read. Okay, this one. Okay, this one is this slide also you read. Is involved 1, 2, 3, 4 with the saving. This one I skip. This one you read. Each one of it have its own explanation. Okay, this one we cover very heavily, SPC, statistical, this one. So you read a lot of theory. Cause and effect analysis, previous slides we use fishbone. This one also we go very deeply. How they do, how they apply. This one you read. Histogram, what is histogram, how you apply it, what you do with the histogram. This one also you read from the PowerPoint slides. Okay. Okay. This one is too easy for this module, so I don't ask this kind of question. You do scatter diagram. So this is non pattern. Every time when you, every time you write a report or there's a data, you need to tell the pattern. So these are the way you discuss lah. So this one no correlation between X and Y. This is have a polynomial correlationship, linear or polynomial. This one negative. Y equal to mx plus c with a negative gradient, negative correlationship. This is a positive correlation. Okay. On you read trend analysis, control chart, normal distribution. Just now already. Upper control limit, lower. This one have another two line above the ULC and LLC. Upper specification limit and lower specification limits. Okay, this one it add another two, but in your test you won't see specification limits. Okay, this one only you see this one in the industry when you focus on the process. Okay, so this one, okay, so for example, with Six Sigma limit, only 2 defects per billion is allowed. So for example, this one. So attribute or normal standard variation. So if you only have 1 sigma, your defective part per billion, it can be 300,000 defect part per billion. But if you increase your sigma from 1 to 6, 6 means you control 99.9999% of the range of the data you measure, means you only allow 2 defects out of billions. Because you have 99.999 data, and every data point have to fit between the upper and lower limit. So you only allow 2% or 2 out of billion can only fail. So it depends on how good you want to control your process. For example, Motorola, they have Six Sigma limit, means in their production, they control up to 2 defects per billion. So if you are a customer from Motorola, then you are very headache. If you are the in-charge person in Motorola, you'll be very happy. But if you are the supplier for Motorola, you'll be a headache. Because you need to control your process up to 2 defective parts per billion parts. Meaning near to zero defect. Means if you send 1 lot or 100 sample, they check 1 sample fail, they reject the whole lot. Randomly they pick based on luck. They pick, fail, they reject the whole lot. They assume 1 billion parts all are defect if they control up to 6 sigma. Okay, so when you go to work later, please ask what is the allowance for the defect that they. Okay. So this one you read. This one. This one we already cover lah. It's just more information for P chart, C chart, and so on. This one is sampling. So single sampling, double sampling, multiple sampling. Okay, so single sampling means you only single run. Double sampling means you have a small sample size tested. Multiple sampling means you have a different small lots. Okay, this one you read. This one some history about Six Sigma. This one also you read. Lean Six Sigma. What is Lean Six Sigma? What is Kaizen? Kaizen, Japanese word. Kai is take part. Zen is make good. It means you have a improvement. Kaizen is an improvement approach. 5Y. This is to build the fishbone. You need the 5Y process. Fukuyoki, again, avoid stupidity to avoid error. Right? So, three principles of Fukuyoki: make wrong action more difficult. That's why they, for example, SIM card, if you have a wrong orientation, you're not able to push the SIM card in. Make mistakes obvious to the person so that the mistake can be corrected. So this one, like your ATM card, the orientation, they put a photo there, you put in the correct way. Detect error. So this one is there's a jig there. So for example, QC parts, they have a QC jig. They just push the thing in. If cannot push, then fail. Can push, then pass. For example. Okay, seat belt. All these things are Six Sigma. Your heart is a Pokayoki example. Your heart, because they have valve. You learn biology, right? So all these valve from left to right, up and down is a Pokayoki design. Okay. So another one, more advanced one, is the one that recently we have, the smart car. We have all the sensors. They are actually Pokayoki things lah. You send something, they make correction or give warning. Quality check, this one you read. Okay, this one you read. Oh, so you read, okay. Although I spend lots of time checking this one, but you read this one for your info. Okay, so which of the following not part of the general accepted view of quality today? Okay, we can inspect. I think this one you read now. Again, who define quality? Customers. Customers. These are all above. Quality control. True modern quality management. This one all. Quality defined by customers. Quality become competitive. Quality is an integrated part of strategic planning. So a company detected to quality usually provide training for all. Then quality guru zero defects is by Cosby. Cosby, he say that zero defect is achievable. Okay, again, I'll go and read. Demin, Joran, and Cosby, the chart, the table, go and read. What do you think about the quality improvement? This one you read. Okay. So They mean again, they mean they focus on management. 85% have to make by the management. 15% workers, right? Return view, quality inclusion. Okay, that means cycle again is plan, act, check, do, and plan. Continuous improvement. I think this answer is wrong. It should be plan, do, plan. It should be A, I think. Order of course. I think 13 is wrong answer. Right. Okay, this one you read. This one you read. This one also you read. Okay. Okay, then I think we save this one for Friday class. Okay. All right. See you on Friday.